Hi, everybody. Today we're on Unit 8, Lesson 5, and this is just sort of a miscellaneous wrap-up day. So we're just going to kind of be combining a couple of the previous days and reviewing some things. The first thing we're going to start with was our inverse trig. And I just want to remind you, whenever we see any of these expressions, it really means to find the angle that gives a certain function value. And that function value is going to be a ratio. Next unit, we're going to be using our calculator to do this, but right now I really want you to understand the meaning of how we're getting these. And if you recall from yesterday, it depends on the ratio and the sign being whether or not it's positive or negative, that function value. And we had special rules. For instance, with the sine curve, if the function value is positive, our answer will be the first quadrant value of that angle that gives that ratio. And if the function value is negative, we're going to use the fourth quadrant value of that angle that gives us that given ratio. So if we look at our first example here, we want to find the angle whose tangent is radical 3 over 3. So hopefully you recognize by now, when you see radical 3 and 3, you should kind of, your brain goes to my 30, 60, 90 triangle. Because when I put my side lengths on, I see, oh, okay. My tangent is opposite over adjacent. 1 over rad 3 is rad 3 over 3. So our angle that gives us this function value, simply by the ratio of the side lengths, is a 30-degree angle. Now I go based on the sine, right? So I have a 30-degree angle. Now, is this function value, right, positive or negative? Because I know that if it's positive, I'm going to use the value of this angle in quadrant 1. And if it's negative, my answer will be the value of this angle in quadrant 4. This happens to be a positive value, so my answer is 30 degrees. In our next example, reading the problem, I want to set up the function value, the cosine of whatever angle has a sine of negative 2/3. And automatically, what I know about my triangles, I don't have anything off my special triangles that give me 2 and 3 like that. So this one, I'm going to have to build a triangle. And when we're working with the sine function, inverse trig, if it's positive, it's in quadrant 1. And if it's negative, my triangle is going to be in quadrant 4. And since the sine is opposite over hypotenuse, my side opposite is going to be negative 2 because it's in the negative part of the y-axis. My hypotenuse is 3. And I'm looking to find that value there. A squared plus b squared equals c squared. So my value is going to be 9 minus 4 is 5. X is going to equal plus or minus radical 5. And in this situation, now that I got my x, it's going to be the positive because I'm on the positive part of the x-axis. So if I want to set up the cosine of this angle, all I have to do now is work off of my triangle. The cosine of this given angle here is going to be adjacent over hypotenuse, or radical 5 over 3. Okay. So I went back and I reviewed an example of something that you work off the triangle, an example of something where you have to come up with your own triangle. One thing we didn't get to in the lessons this week is average rate of change on a given interval. Now, I'm just going to try to incorporate average rate of change on a given interval when we're working with different types of functions, because it is something you're going to see in calculus next year. So if we recall from earlier in the year, if I have some given function, f of x, and I want to find the average value, I'm sorry, the average rate of change on that given interval from A to B, the average rate of change is really the slope of that secant line. That's a really big concept. And hopefully you recall from earlier in the year, we set up our formula as f of b minus f of a over b minus a. We set up our function notation formula for the slope of a secant line. Let's try to apply this to a trig function. So basically, I want to find the average rate of change of y equals sine x on the interval 0 to pi over 2. I'm going to sketch a little picture just so we know what we're talking about. So here's just a kind of real quick sketch of a sine curve. And basically, the average rate of change is going to be the slope of that line. That's what we're looking to find. So to set up our formula, f of b, since our function is sine x, my interval is from a to b. I'm going to plug in, so I'm going to find sine pi over 2 minus sine 0 over pi over 2 minus 0. And now I'm just going to evaluate this. The sine of pi over 2, looking in front of me, is 1. The sine of 0 is 0 over pi over 2. So I have 1 over pi over 2. And we know when we have a complex fraction like this, and we want to simplify it, we can just, dividing by a fraction is the same as multiplying by its reciprocal. So the slope of this line is 2 over pi. In other words, it's about 2/3. That's really what's going on there. Okay, and that's it. So, this was something new I wanted to kind of talk about today. Average rate of change. Maybe, you know what? Let's just hop and let's try one more easy one. Easy one. So let's find the average rate of change and let's say y equals 2 cosine x on the interval. So from x equals pi over 2 to x equals pi. So if I think about it, 2 cosine x is just that guy there, right? It's just steep or stretched. And we're going from pi over 2 to pi. So that's basically, we're looking for the slope of that line. Notice you really don't even need the picture. You can do this without the picture. As long as you have the function and the interval, you can set it up. So the slope of this secant line is going to be f of b. Now in this case, this interval would be pi over 2 to pi. There's your a value, there's your b value. So the slope of the secant line is going to be 2 times the cosine of pi minus 2 times the cosine of pi over 2 over pi minus pi over 2. F of b minus f of a over b minus a. Now I'm just evaluating this. What is the cosine of pi? Not even going to look at my original. I'm just going to think about my cosine graph. The cosine of pi is -1. 2 times -1 minus 2 cosine of pi over 2 is 0. Pi minus pi over 2, so that's 2 pi over 2 minus pi over 2, if you want to kind of think of it that way, right? Because I have to get, if I want to subtract that, so 2 pi over 2 minus pi over 2 is going to just be pi over 2. And just finish up doing your calculation. -2 minus 0 over pi over 2 is -2 divided by pi over 2, which is -2 times 2 over pi, -4 over pi. So just working through the math and evaluating the function that you need to is really what I want you to try to practice here. So basically, I have one more practice problem on this page. Sketch the graph of y equals 2 times the cosine of 1/2 x on the given interval 0 to 2 pi. Then after you sketch that, I'd like you to find the average rate of change and then identify the x-intercept. And I have this work all worked out here, because at this point in time, you guys should be able to work through this problem on your own and be able to kind of check yourself with my work as you go through it, okay? So that's all I really wanted to talk about today. Thanks, and see you soon.